Hello, just some notes today. This might be a review for you and it won't take you very long. So you're welcome to look at the review if you want, but I'll just have you do that tomorrow. So that's not so much every day. Okay, so we're going to talk about systems of inequalities eventually, but today we're just going to talk about regular linear inequalities. So basically, inequality means it does not have an equal sign. So you're talking about like a less than, a greater than, a less than or equal, or a greater than or equal, or even a does not equal. So basically, you're going to have what looks like a line, and instead of an equal sign, you have one of these inequality signs. Okay, it says A and B both can't be 0 because then it would not be a line, and these are linear inequalities. And basically, when you graph it, what you'll do is you're going to graph this, and it's going to be the boundary line. And you remember how we talked about lines? For example, let's just do y equals x plus 2. There are infinitely many answers that make that true, x and y, right? You can make a t-table, 0, 2, 1, 3, 2, 4, and we could graph it. It would be a picture of all the answers. Like these are those lattice points, but when you connect the dots, there's all these in-betweeners too, because I could plug in 0.1 and I could get 2.1. So I missed the dots, but all of these are the answers. Well, when you change it to a greater than sign, let's say greater than or equal to, not only are all these points on the line make it true, but there's other points that make it true as well. Like this point here, which would be 0, 5. 0 plus 2, 5 is bigger than 2. So this is part of the answer, and this is part of the answer, and this is part of the answer. And all of these are part of the answer. So we get a solution set called a half plane, because there's infinitely many answers up here that make it true as well. Now, there's answers down here that make it not true, but we're only looking for the solution set. So basically, inequalities have more answers than lines, and you will do some shading to show what those answers are. So here's what the graph would look like. You first graph what they call the related equation, which is the equal sign one. And you already know how to graph lines, so that's not a big deal. Then the rules are this. If you have a less than or greater than sign, because it does not equal, we graph with a dashed line. You see how this is dashed? You would graph with a dashed line. It was a less than or equal or greater than equal, then you go ahead and do a solid line. So you'll want to write that in your notes. Those will be dashed. These will be solid. Okay, because it's dashed, that's actually not part of the solution. Look, that point 0, 3 is not part of the answer because 3 is not less than 0 plus 3 or 3. It's not less than that. It could be less than or equal to, but it's not that. Now, they suggest that you just graph the related equation, that boundary line, and then pick a point. For example, 0, 0 is always very easy to pick because you're either going to be on the top or the bottom. And if 0, 0 makes it true, then you shade it down here. If 0, 0 made it false, then you would shade up here. The other thing you could do is you could remember that less than or less than equal to means lower, which means below. So you would shade below the line. Greater than equal to, greater, bigger, above the line. You could do that as well. Or the test point. Either way will work. So we're just going to do a couple examples and that'll be it. Here are the steps. The steps are graph the equal sign one and decide if it's dashed or solid. So graph the one with the equal sign and then decide if the line is going to be dashed or solid. Then they're telling you to pick a point. 0, 0 is always a good point to pick. And if it makes it true, then they call this a test point. If they make it true, then shade that side. If it's false, shade the other side. So sloppy. Okay, so Don't forget, the other thing I need you not to forget is when you're working with inequalities, if you divide both sides or multiply by a negative, you need to flip the inequality. You need to flip the direction of that arrow. All right, I think I got 3 examples, and then that's it for today. So here we go. 3x plus 4y greater than or equal to 12. So we're going to go ahead and get y by itself. Divide all the friends. Okay, so get y greater than or equal to negative 3/4 x plus 3. Now, because it's equal, it will be solid, and then we will just graph this line. Y-intercept is 3. Slope is negative 3/4. So down 3 over 4. It will be solid. So there's your line. Now, which half plane will make this true? So we're going to pick 0, 0, and we're going to see if it's true or not. You can plug it into either one if you want to. I'll just plug it into here because it's all pretty easy. If you plug 0, 0, I mean, this would be 0 and this would be 0. Is 0 bigger than or equal to 12? No, 0 is not bigger than 12, so that's not the answer. The answer is up here. Your other possibility you could do is say it's a greater than, bigger, above the line. Okay, these are the special ones. X is greater than negative 3. Well, where does x equal negative 3? Right here. It'll be a dashed line because it has no equal. And where is x bigger than negative 3? Well, 0 bigger than negative 3? Yes. So we'll plug it in over here. And last one, y is less than equal to 4. This time it will be a solid line because of the equal sign. Where does y equal 4? Right here, solid line. Is 0 less than 4? Yes. So we're going to shade down here. All right, that's it. Just do the one today. Like I said, if you go, this would be a good day to catch up on your test review if you're behind. We're going to do systems of 2 tomorrow, and then you should be able to finish up your test review. Okay.